Today we are going to talk about finding the surface area of rectangular prisms. We already know that rectangular prisms have a total of 6 faces. And then we also know that they're going to have 2 bases that are rectangular shaped, they run parallel, and they are congruent. We also know because it's a rectangular prism, that opposite lateral faces are also going to be congruent. Okay, so what this looks like, drawn out, we've got our rectangular prism here. When we open it up into a net, we have 2 bases, those will be congruent. And then we have 2 sets of lateral faces that will also be congruent. So when we do this, we have a formula that we can use, and that formula is surface area equals 2 length times width. That'll cover this, the bases. Your bases are length times width, so it'll cover 2 of those, 2 length times width. Plus, we will add that to, let's do our width times height. So our width and height, that'd be these 2. And then we will add it to our final side, which would be that front one, those longer ones, which would be length times height. Now, 2 length times height. Because we have 2 of every single side, we just need to multiply every side by 2. Then I can check myself, okay? I need 2 lengths, 2 widths, and 2 heights. If I somehow got 3 lengths and only 1 width, then I would know that I didn't get all my measurements accurately, okay? So I account for every single one of my sides here because I have every combination. I have my length and width, I have my height and width, and I have my length and height. Now that means that sometimes your formula might look different. You can mix it up. The way to check yourself, again, is that there's 2 lengths, 2 widths, 2 heights, and that you multiply every set by 2. So let's give it a try with some numbers and kind of work that out. So if this is our rectangular prism, again, I'm going to start with my formula. S equals 2. Let's do length times height first. Plus, let's switch it up this time and do length times width. And 2 equals height times width. Now, like I said, this is a different formula than this one, and that's okay. Again, I have 2 lengths, 2 widths, and 2 heights, so I have accounted for every dimension, and I'm good to go. Okay, so now let's call this my width, this my length, and I've got my height right here. Okay, so I like to label those to make sure, I account for every part. All right, now we plug it into what our formula. We substitute everything in. Okay, so 2 times my length, which is 5, times my height, which is 6. I add that to 2 times my length times my width, add that to 2 times my height times my width. Okay, so I now have every dimension twice. 2 5s, 2 6s, 2 3s. So I have, again, accounted for every part here, and I'm good to go. All right, so now I go ahead and I want to see this next step. You may plug everything into a calculator, but we are going to see this next step. So when I have 2 times 5 times 6, that is going to get me 60. I add that to 2 times 5 times 3, which gets me 30. And then lastly, I have 2 times 6 times 3, which gets me 36. Now all that's left is to add this all up. 60 plus 30 plus 36 gets me 126 inches, and that's going to be squared. All of this was multiplying, and we were finding the area of all of these, so we will have inches squared for our surface area. Again, I want to account for every side, every dimension. Two sides exactly are the same. That's why we multiply by 2. And then I make sure I have 2 lengths, 2 widths, and 2 heights to set up my formula. The order can differ. And then I plug in, substitute in to simplify down to my total surface area being 126 inches squared.